Hello everyone and welcome back to ZakLiT educational channel. So this video we will discuss about one of the very frequently asked statistics concept, that is Poisson's distribution. So this question is one of the frequently asked question for NET, GATE, MSc or PhD entrances, and in this video we will know the basics, concept behind that, along with the kind of questions which are asked in the NET or GATE examinations. So get ready with your notes so that you can write down all these things which we are going to discuss in this video. So without much delay, let's get started. So before starting this video, I would like to say that you can join our Telegram group Learn for the Environment. Link will be provided in the description for daily quizzes for the environmental science entrances, so that you can strengthen your preparation and check whether you are going in the right direction for your preparation or not. So now we'll discuss about this Poisson distribution. Why this name is given as Poisson? It is not poison that is very harmful. It is Poisson, which is the name of the scientist behind this concept. Yes, this was discovered or named by the Simeon Denis Poisson. So that's why this distribution in statistics is called as Poisson's distribution. So here it is a type of discrete distribution. It is not a continuous distribution. So here why I am discussing all these things, because the questions are nowadays coming in the form of statements. So in statement it can give that whether it is a discrete distribution or not. So you should note down this Poisson distribution is a discrete distribution. So no need to go deep inside the concept and all. I will tell you only what is required for the examination and to get the marks, that is full marks you will get. So it describes the random events that occurs rarely over a unit of time or unit of space. So that is the definition. But it differs from the binomial distribution. Binomial distribution, you must be knowing that n, p, q, you know that is the binomial distribution where these functions are used, where n is number of trials, p is the probability of success rate, q is the probability of not success rate or failure. So this is different than the binomial distribution. How I will tell you? In the sense that we count the number of success and number of failures, as we know, that is p and q respectively in the binomial distribution, while in this Poisson distribution the average number of success in given unit of time or space is calculated or it is considered. So this is the difference between the binomial distribution and Poisson distribution. In Poisson distribution, average number of success in given unit of time or space is considered, but in case of binomial distribution we count the number of success or number of failures in the event. So till this I hope you have noted down. Next thing we will write down is that the probability. What is the definition of this Poisson distribution? The proper distribution is that this proper definition is the probability that exactly x events will occur in a given time is as follows. So this formula is very important. Yes, formula to find out Poisson's distribution probability is given as p, x is the events. So how much events we will be calculating, x will be taken, is equal to e to the power minus lambda multiplied by lambda to the power x, where x is the number of events, divided by x factorial. So here x can be 0, 1, 2, 3, 4 based on number of events. So here lambda is what? Lambda is the average number of occurrences per unit of time. This thing you should note down. Lambda is the average number of occurrences of that events per unit of time. So here lambda is given as np. N is number of trials and p is the probability of success. So here in some cases lambda is also denoted as what? It is denoted as mu also. So lambda or mu, whichever it is given for Poisson distribution, both means same, that is the average number of occurrence per unit of time. So this called as the probability mass function of Poisson distribution. This is the formula. Px is equal to e to the power minus lambda, lambda x by x factorial, and lambda can be sometimes written as mu also. So now let's solve a question from the UGC NET environmental science paper for this concept, that is Poisson's distribution. So guys, now it's time for noting down all these things, because this is the solved problem for this question. Let us read the question first. The question says a random variable x follows Poisson distribution. So there is a variable which is random, which is x. It follows the Poisson distribution such as what? It is given that the probability when x is equal to 1 is equal to the probability when x is equal to 2. So this is the given thing, you should note down, this is the main thing. And now it is asking, now consider the following statements. That means we have to check all these 4 statements and we have to select which statements are correct. So here we have to select whether A, B, C are only correct, B, C, D, A, B, D, A, C, D. So for that we should know whether these statements are correct or not. First let us read the statements. The statement given here is the mean of the Poisson distribution is 2. We will check here. Variance of the Poisson distribution is also 2 given. Probability when Px is equal to 0 is equal to e to the power minus 2. Probability of Px is equal to 0 equal to P, that is probability when x is equal to 1. So no need to worry and get confused by all these terms. We will simply solve with the help of that same Brahmastra formula, that is for the Poisson distribution, that is P, that is the probability of x when mu is the average thing which is given. Here in the previous slide we have considered as lambda, but here it is given as mu, we have taken as mu. So same thing, so the formula is probability of x, that is the random variable where mu is the average, it is given as e to the power minus mu multiplied by mu to the power x by x factorial. So where mu is equal to mean, or which is also lambda, I am repeatedly saying. So this is the formula which we also knew in the last slide. So this formula we will use to find out the whole thing for this question. So here given thing we should note down, here it is given, I was telling you it is very important, probability of x is equal to 1 is equal to probability of x is equal to 2. So here what we will do, probability finding, the formula is this one. So here in place of x, here one numerator x is there in the power, in denominator also x is there. So in place of x we will replace with 1, and here in the right hand side we will replace the x value with 2. So what we will get? We will get e to the power minus mu, we don't know the mu value, and mu to the power x, that means here we will take 1. Similarly here in the right hand side mu to the power x means mu to the power 2, because here x is equal to 2 we have taken. Similarly denominator x factorial, in the left hand side it will be 1 factorial, in the right hand side denominator will be 2 factorial, because here we have taken x is equal to 2. And this thing where we got it from the given, that is in the question it is already given here, Px is equal to 1, Px is equal to 2, that means both the probability are same. So here after solving this, what we will get? Here e to the power minus mu, e to the power minus mu cancelled, and here mu 1, that is mu to the power 1, mu to the power 2, that means here mu will be cancelled, only 1 mu will be there in this right hand side, divided by 2 factorial means 2, and here it will be how much? It will be 1 by 1, that means 1. So here after solving that we will get 1 is equal to mu by 2 or mu is equal to 2. This we will get, and mu we know it is the mean, that means that is the average thing. So here we got from solving this thing, that is probability of x is equal to 1 is equal to probability of x is equal to 2. After solving this thing we got mu, that is the mean, is equal to 2. So here you should check, in the first statement is given the mean of this Poisson distribution is 2, that means it is correct. So here on all these 4 options, 3 options will be now considering, we will be considering where A is given correct, because we know that mean of the Poisson distribution is 2 now by solving these equations. Now one concept more you should note down for this Poisson's distribution. In case of Poisson's distribution, the parameter mu is same as variance. Yes, mean and variance both are same in case of the Poisson's distribution. So that is the main concept behind this. You should note down every time it is asked in some or other twisted form. So here variance will be same as mean, and variance it is asking that, also telling Poisson distribution is 2. So both these statements are correct now. So A and B are correct. That means now only 2 statements are remaining. That means ABC or ABD. Now we will check whether C is correct or D is correct. If one of them is correct, then we can go for either one option or the third option. So for that thing, we will go to the next slide. So now we are having only 2 options left. We are close to our solution. Now we will check whether the probability P when x is equal to 0 is equal to e to the power minus 2 or not. For that thing we will write the same formula. We all know that this is the Brahmastra of the Poisson's distribution. Probability of x when mu, that is the mean, is given is equal to e to the power minus mu, mu to the power x by x factorial. But here to solve this thing, we will take probability of x is equal to 0. So in place of x, we will put the 0 value. So what it will become? It will become like this: e to the power minus mu, mu to the power x means mu to the power 0, and divided by x factorial, that means 0 factorial. And we all know from the school days, that means 0 factorial is equal to 1. So e to the power minus mu only will be in the right hand side, and probability of x is equal to 0 will be how much? Here we know the value of mu, we have calculated in the previous slides. How much? It was 2. When we calculated the mean and the variance, both were 2. So we will substitute the mu value as 2, and here you can see in right hand side, by substituting mu value as 2, we'll get px is probability of x is equal to 0 is equal to e to the power minus 2. That means 2 is the mu, that is the average which we have calculated. So this is the thing which is given in the third statement, that is C. So it is also correct. So A, B, C are correct. That means option 1 is our correct option, because here D is given. That will not be considering, because no need to solve this thing, just simply waste of time, because we have already got A, B and C are the only correct option for this Poisson distribution given. So I hope you have learned something new from here. You can again watch this video if you want to rewind that, revise these things. So I hope you have enjoyed this. Don't forget to subscribe the channel to get all further updates and prepare for the environmental science entrances. Keep smiling, believe in yourself. See you guys in our next video.